Hello and welcome to Service Management General Concepts, Part 2. My name is Lowell Amos. I'm an ITIL expert, and for the next few minutes I'm going to talk to you about some more of the basic principles of service management. So let's get started. In this lesson we're going to cover some basic ideas and concepts that are important for you to understand. The first is the distinction between customers and users. We talked a little bit about that in the Service Management General Concepts Part 1. We're going to talk about defining processes. What are processes? What's the generic process model? And what are some of the attributes of processes versus functions? We'll talk about the importance of metrics, the Deming cycle, and a RACI model as a way to provide accountability into processes and services. And we'll also spend a little time on the idea of service automation. So let's get started. It's important for you to understand the distinction between customers and users. These are foundational definitions that are used throughout the framework. A customer of an IT services buys the services and typically agrees to service level agreements with the service provider. The primary interface to IT for customers is through the service level management process. This is the process that engages customers and defines, documents, agrees, and monitors the levels of services that are required. A user, on the other hand, is a person who makes use of the IT service. This is the person who has email accounts, or maybe requests things through the service desk. The main point of contact for users to IT is the service desk, as the single point of contact where users can get help, support, or request things. They may do this in an automated way, through a service catalog, or a website, or they may make a phone call. So let's talk a few minutes about processes. What is a process? A process is a set of coordinated activities that turns inputs into outputs. In general, processes respond to specific triggers and have a defined beginning and end. A process can be defined by those attributes of the inputs, the outputs, the specific triggers, and the procedures under which they are executed. A procedure is a set of steps to follow. A work instruction may be a more detailed set of instructions when required. A function, on the other hand, is a logical grouping of resources that exist within the specific context to do a specific type of work. A classic example of a function in the ITIL framework is the service desk. It's different than a process in that a service desk exists. It does not have a defined beginning and end. It is a set of resources and capabilities that are there to perform a specific type of work. The service desk may execute processes, like the incident management process. If a user experiences a service outage and the service desk is contacted, they may perform some or all of the activities of the incident management process. Functions provide stability to organizations and provide a basis for management. A process may cross many different functions. In the case of the incident management process, a service desk may receive the initial call, identify and log the incident into the incident management system, and then escalate that incident to a technical group in application management or technical management from a functional point of view. So processes can cross functions, and functions or organizations that provide stability in a way of managing work. It's important that you can make the distinction in your mind between processes and functions. A process should have a process owner. This is the role or person that's responsible for ensuring that the process is fit for purpose, and the process owner is accountable for the quality of the outputs of the process. A process manager is the person responsible for the operational management of the process. Processes and services can have many managers, but only one owner. More on that when we get to the RACI framework. Here's an example of a generic process model. Processes have enablers, things like resources and capabilities. They have inputs, outputs, and respond to specific triggers. In the center box, you can see the process activities, the procedures, work instructions, roles, metrics, and improvement opportunities. On the left side, there are inputs, and on the right side, there are outputs. And that's the primary purpose of a process, is to convert inputs into outputs. The top box represents the process control layer, or governance. It defines the policies, objectives, and documentation of the process, and provides a basis for measurement. These are the basic overview generic process models. Process control. If we take the top box, this is about planning and regulation of a process, or governance. Processes should have policies, defined owners, documentation, and objectives, and a mechanism to provide feedback so that we have a basis for measurement and controlling the process. There's an entire science about process control, and is well beyond the scope of the ITIL Foundations course. However, know there is a body of knowledge that specifically deals with the idea of process control. The process itself is the set of coordinated activities that turns those inputs into outputs. In the case of the incident management process, there are activities, procedures, work instructions, measurements like mean time to restore service, process roles, this might be the service desk agent or an escalation team, and process improvement opportunities. The specific trigger for the incident management process might be when the phone rings at the service desk and a user reports a problem or an issue. That trigger will then start the incident management process, and the service desk agent will begin doing activities like identifying and logging and categorizing the incident. The service desk agent sits in the role of the incident process. Likewise, the incident may become escalated to another functional group for Tier 2 support, or perhaps to a specific technical team like the networking team. So the incident can cover many different functions and roles, and those activities are what defines the roles. A role is defined as a set of interconnected activities to perform some objective within a specific context. In the example of incident management, the context is support. The process should also produce outputs. In the case of the incident management process, the output is a restored service to the user. So from that perspective, the incident management process takes an input, such as a user reporting an issue or incident with a service not functioning as designed, and the incident management process has the objective of restoring service for that user. That's the output. In order to do that, there are specific activities, procedures, work instructions, roles, and metrics that all must come together for that to occur. All governed at the governance layer by specific policies and process design. The process enablers are those resources and capabilities that we talked about in the Service Management General Concept Part 1. They're the things that we need in order to enable that process to occur. Things like telephones and computers and ticketing systems from a resource point of view, as well as knowledge and experience from a capability point of view. Those process enablers, or resources and capabilities, are what allow the process to function. Processes have specific characteristics. They're measurable, they have specific results, they have customers, they respond to specific triggers or events, and of course they turn inputs into outputs. So let's talk a few minutes about metrics. A metric is something that is measured and reported to help manage a process, IT service, or activity. These sometimes are expressed as key performance indicators and are oftentimes related to critical success factors of the service or process. In the Continual Service Improvement publication, there's a great deal of focus on the idea of measurement and metrics. There are three types of service management metrics. There are technology metrics. These are metrics that are relatively easy to gather through monitoring tools, and they measure a specific component or configuration item of a service and report back a variable of interest. For instance, server utilization. Another might be capacity of a disk. These are technology metrics and can be used to determine and manage that particular asset. Service metrics are the end-to-end view of the service from the customer point of view. Service metrics are oftentimes difficult to measure directly, although there are some methods that can be used, like synthetic transactions and others, to identify performance issues. But in general, service metrics are oftentimes computed from technology metrics if we understand the architectures, both from a technical and management point of view, underpinning the service. And process metrics determine the overall health of a process. Again, a key performance indicator of the incident management process is how long does it take from the time we identify an incident to restore service to the user. This is defined as mean time to restore service and is intimately related to availability, which is a critical component of warranty. The process metric, or key performance indicator, would be mean time to restore service, and over time, we would like that to trend down. And that's the value of metrics. It provides a feedback loop, if you will, to the service management lifecycle. and gives us a basis for acting and knowing when things aren't going as well as we would like them to. Or likewise, it's a way to report to a customer that we are meeting the requirements that we determined in service design. Metrics are generally related to critical success factors. A critical success factor is what must happen in a process, project, or service for it to be successful. And key performance indicators are specific metrics that help identify or are related to those critical success factors. They give us insights into whether we need to take action to manage the process differently or take improvement actions. In the case of the incident management process, its mean time to restore service is one of the key performance indicators or critical metrics. If we notice for a specific critical application that the mean time to restore service is taking longer and longer over time, we would probably want to understand why that's occurring and take action to bring that back into alignment with where we would expect it to be. Metrics can be both quantitative or qualitative. Many times, service desks are evaluated on qualitative metrics such as customer satisfaction surveys because they provide valuable insight not only into the quantitative effects of whether the service desk is providing good service, but also into the customer point of view. It's important to understand that value, that idea of utility and warranty, is highly dependent on customer perceptions. Value is a concept. It's not something that can be measured directly, which is why we want to try and look at our performance across multiple different dimensions to make sure that we have good insights into what our customers value and how they view us as an IT service provider. There are different types of metrics that are identified within the ITIL framework. These come in the forms of compliance, efficiency, effectiveness, and progress metrics. Understanding each of those metrics is beyond the scope of the Foundations training. However, there is a great deal of information in the Continual Service Improvement publication around metrics and how they can be constructed. The ITIL framework provides great insight into the critical success factors and industry-accepted KPIs from a good practice point of view for each of the processes across the ITIL framework. So let's take a minute and talk about critical success factors and KPIs from a scenario point of view. If we take the incident management process and the service desk, and we identify a critical success factor for the incident management process is our ability to quickly restore service to the user. That's the critical success factor. We then need a way to link an objective metric to that critical success factor. One might be mean time to restore service, and it's one that we've covered at length. But there could be others. There could be the ability to look back in the design process of availability management. If over time the incident management process was not producing the mean time to restore service that was acceptable to the customers and we needed to take action, another incident type that we might want to review are those incidents that are infrastructure incidents that do not have customer consequence. For instance, if a RAID drive fails, or one platter on a RAID drive fails, there will be no customer impact, but there will still be an incident. We might want to understand what is the relationship between the incidents that happen in the infrastructure and how many of those on a percentage basis impact customers. That could be another key performance indicator of service design. Hopefully you can see that critical success factors are important to understand in order to manage processes and services on behalf of customers to create value. Those critical success factors are measured using key performance indicators or metrics. Making sure that you get the right metric is important from a management point of view for incenting behavior. The old adage of tell me how you're measured and I'll tell you how you'll behave is true as it ever was. So let's take a minute to talk about the Deming cycle. Edward Deming came up with the Plan, Do, Check, Act framework as a method for continuous improvement. It is a circular and ongoing management philosophy to continually improve over time. Plan, Do, Check, Act is an important component of the ITIL framework and is covered at length in Continual Service Improvement. The RACI model is an accountability model, and it's an acronym. It stands for Responsible, Accountable, Consulted, and Informed. If we take a specific process or activity and map the activities or procedures within it to roles, we can then fill out a RACI chart. In the example on the screen, the role, there's an activity of write code. The role across the top of developer, administrator, and manager. For that specific activity, the developer is responsible. Responsible means that they will take action to make sure the activity is done. The administrator is blank, and the manager is both accountable and informed. When we look at the install of the code on the server, the developer is consulted, the administrator is responsible, and the manager is both accountable and informed. There are a couple of important points that I'd like to make. The first is, if we look at the rows, write code, and move from left to right, it is important that only one role be accountable for that activity. Having more than one role accountable for any specific activity is effectively having none. Likewise, if we look down the columns, we can see that the manager has a lot of accountability and only one R. If we do this across processes, and we can begin to see both A's, R's, I's, and C's stacking up in one particular role, we might have a resource issue. We may have too much activity assigned to any one role, and it's probably worthwhile to consider spreading the work out differently. So again, multiple people can be responsible for any one activity, but only one role should be accountable. The RACI model is a powerful accountability tool, and I encourage people that work with me to use it often, early in projects and initiatives, to identify exactly who is going to do what, and make sure there's agreement and understanding about the activities and the roles and the relationships between them. Let's talk about service automation. Service automation is a powerful way to be able to drive utility and warranty through both processes and services. It should improve the performance of service assets, and this makes sense. Computers are great at repetitive tasks. It allows capacity to more easily be adjusted. Let's face it, computers don't need to sleep or eat or take time to themselves for their friends and family. So capacity can be easily added. There are fewer restrictions on resources, and automation provides a basis for measuring and improving resources by holding constant the human resource factor. This is an important point. Automation provides an objective way to capture data that isn't dependent on human perception, and therefore gives us better the warranty effect or less scatter in the data. It reduces the variance from a statistical point of view. And many optimization problems are just beyond the capacity of human agents. There are deeply embedded problems such as scheduling, routing, and resource allocation that get so complicated that they're beyond the ability of a human agent to understand. However, computers can manage all of that data quickly and efficiently. These are some of the benefits of service automation. We'll talk more on that as we get through some of the design phases. So let's review some key terms. We talked about processes as a set of coordinated activities that turns inputs into outputs. They have specific triggers. They have a governance layer, a process layer, and an enablement layer. And it's important for you to understand how processes work, because the ITIL framework is primarily a set of good practices from a process point of view. A procedure is a set of steps to follow, and a work instruction may be a detailed set of instructions that are specific to an individual role. A function is a logical grouping of roles and measurements that execute a defined process, or a part of a defined process. In ITIL, there are 4 functions: the service desk, technical management, application management, and operations management. And we're going to talk about each one of those as we work through the course material. A process owner is the person that is accountable for the output of the process. And the process manager is responsible for the operational management of the process. This ties directly back to the RACI chart that we covered a couple of slides ago. A metric is a way to measure an output. It's something that takes a measurement and reports an activity of a process or service. It's tied generally to a critical success factor, which is what must happen for a process, project, or service to be successful. A key performance indicator is a type of metric that helps us manage a process, service, or activity. It's oftentimes expressed as a ratio, mean time to restore service, for instance. And service automation is a way to design and improve performance of a service, of those service assets or resources and capabilities, and improve utility and warranty. So, before we move on, let's review what we've covered. We covered the idea of customers and users, and how customers interface IT through service level management, and users generally interact with IT through the service desk. We defined the processes and the attributes of processes and reviewed a generic process model. We talked about the importance of incorporating metrics in order to meet critical success factors of both services and processes. And we talked a little bit about the Deming cycle of plan, do, check, act in order to improve performance over time. We'll spend a little bit more time on the Deming cycle in continuous service improvement. We defined the RACI model as an accountability framework for defining who is responsible, accountable, consulted, and informed for a specific activity. And we talked a little bit about the benefits of service automation. I hope you learned something in this, and I look forward to seeing you in the next lessons. Thank you very much.